Okay, for this last example here in section 3.3, we're going to put all these concepts we've learned and actually translate a quadratic in standard form into a quadratic in vertex form. Now, if you remember, a equation in vertex form is y equals a times x minus h squared plus k. Now, you can realize just by looking at this equation, you'll see that we've got x minus h squared. We have this perfect square binomial in here that we don't have in standard form. So that's why we needed to learn this process of completing the square, was to learn how to take non-perfect square quadratics and transfer them into perfect squares. So let's go ahead and look at this. First thing we need to do is we need to isolate our x squared plus bx. Now, we're not solving for x here, so this is not equal to 0. We can't forget about our y here. We have to leave that in our equation. So the first thing we want to do is subtract 16 from both sides. Subtract 16. So what we're going to get here is y minus 16, and that's equal to x squared minus 22x. Okay, now remember, we're going to be completing our square, so I'm going to write a space right here for us to figure out what term we're going to be adding to this one. Now, we take b over 2 and we square it. So in this case, we're going to take b is just negative 22. So we're going to take 22 over 2. So we're going to get 11, and we're going to go ahead and square that. So we get 121. So we're adding 121 to both sides. So we can just do 121 plus y minus 16. So the next step is to go ahead and rewrite this as our perfect square binomial. So you'll see x squared minus 22x plus 121. We're just taking x, and in this case we're subtracting whatever b over 2 was. So x minus 11, and that's our perfect square binomial. Now on this side, we have to go ahead and combine our like terms. So we have y, and we have 121 minus 16. So we have 5 plus 105. And now what we're going to do is we've already got this side starting to look like our vertex form. The only thing we're missing is our k value here. But what you're going to see is that our k value actually comes from isolating y. We're going to want to subtract 105 from both sides so that we can get our y value by itself. So what we do when we subtract y, or 105, we get y by itself, which it needs to be in vertex form, and we're going to get x minus 11 squared, and that's going, and x minus 11 squared, and we have minus 105. Now, you'll see this is in vertex form. A is just equal to 1 in this case. We get our h value from here, and we get our k value from here. So in this case, our vertex is just going to be, it's minus h, so our k value is just going to be 11, and our k value it's plus k. So our k value is just minus 105. And through this method, by turning it into vertex form, we're able to determine that our vertex is at the point 11, 105. Now, if we had a larger coefficient in front of x, for example, if we had 2 or 3 or 4, if you remember, we would have had to divide everything by that value. So our y would have been something like 1/2 y, or 1/3 y, or 1/4 y. And what you would have to do is when you get to this last step here, you'll have that coefficient in front of y that you will have to undo to isolate y. So for example, multiply both sides by 2, or by 3, or by 4. Those are going to be the situations where you have a vertical stretch and you have that coefficient in front of your a coefficient in front of x minus h. Okay, that's all the videos that I'm going to be putting up for now. So if you have any other additional questions, make sure you text me through the Remind app or email me through School Loop. Okay, thank you guys for checking these out.